Dear students, today we will discuss about differentiation of composite functions. Suppose we have a function gx and another function f operates on the function g. These type of functions are called as composite functions. This is denoted by f composition g x. Now let us see how to differentiate these type of functions. Suppose we have a function y which is a composite function, f operating on the function g. In this case, we use substitution. What we do, the function gx we substitute by some other variable. We can use any variable other than x and y. If you want, you can use z. If you want, you can use u. If you want, you can use t. Any variable you can use. So what we do, we substitute our gx as t. In this case, our y will become f operating on gx. Now gx you are substituting as t. So the function y will be equal to f operating on t. Now in this case, y is a function of t. It means I can find dy by dt, or we can say that because y is a function of t, so I can differentiate y with respect to the variable t. Same way, t is a function of x, so we can find dt by dx, or we can say that because t is a function of x, so we can differentiate t with respect to the variable x. If I multiply these two, this will give me dy by dx. This rule is called as our very famous chain rule. And this method of substitution is known as substitution method. Now let us solve a question. y equal to sine x square plus x. Find dy by dx using substitution. So let us solve it. Y equal to sine x square plus x. If we observe the function properly, we can very clearly state that this is a composite function. If we observe the question, it is given that y is equal to sine x square plus x. So very clearly we can say that it is the combination of two functions. One of them is the sine function and second is the quadratic function x square plus x. Clearly, sine is operating on x square plus x, or we can say that sine function is operating on the quadratic function. So this is a composite function, and we have already discussed that in this case, when we want to use substitution, we will substitute our x square plus x as some variable. I am using t. So we will write it as, put t is equal to x square plus x. In this case, our y becomes sine operating on x square plus x, and x square plus x you are putting as t. So y is equal to sine t. Y is equal to sine t. Now here itself we will write t is equal to x square plus x. So t is a function of x. Therefore, we can differentiate t with respect to the variable x. So we can find dt by dx. And when I differentiate, I will get derivative of x square will be 2x plus derivative of x will be 1. Same way, y is a function of t. Y is equal to sine t. Because y is a function of t, so we can differentiate y with respect to the variable t. Therefore, dy by dt will be equal to, we know that derivative of sine t will be equal to cosine t. And using chain rule, we know that dy by dx is given by dy by dt multiplied by dt by dx. Let us put the values which we have already evaluated. Dy by dt, that is cosine t multiplied by dt by dx, that is 2x plus 1. And because in the question the function is given in terms of x, so the final answer should also be in terms of x. So therefore we will put the original value of t, that is t is equal to x square plus x. So here t we will replace by x square plus x. So the final answer will be cosine x square plus x multiplied by 2x plus 1.